I cannot comment what IPCC says because the conclusions are based on the models which have assumptions. And we know the models always have some restrictions. They do not consider radiative transfer, and this is the main deficit in their model. So we cannot rely prediction on the model. What our prediction, this is based on the observations of the sun.
Good day, dear strategists and possible new viewers. Today we have the joy of being able to welcome Dr. Valentina Zharkova from the University of Northumbria. Dear Dr. Zharkova, thanks for taking the time and welcome. To get started, I would ask you to introduce yourself and elaborate a little on what you have been working on until recently, as well as your works on today's interview topic. To put it quite simple, you are questioning the current perceived majority consensus on us facing continuous global warming, but rather suggest that we might be facing another little ice age, and this much sooner than 2100. Did I encompass it correctly, and would you please elaborate?
Yes, so I'm a professor of mathematics in Northumbria University, emeritus now, and a director of the private limited company, that VS Research Enterprise, where we do our research on solar activity. So my main topic research was investigation of high energy particles and radiation and the spectral observations and different wavelengths from high energy, hard X-ray, soft X-ray, to optical emission and hydrogen and solar flares. I am author of 2 books and 16 chapters in the books. And another book is preparation now. Hopefully we'll submit it at the end of the year. So this is what my research. I started doing research in solar activity out of curiosity after the European project, European Grid of Solar Observations, which finished 2005, and we created large databases of the solar activity data, SunSpot, active region, and filaments. So we tried to do some statistical analysis, and when we started doing it, we suddenly came up with the discovery of 2 magnetic waves which produce solar activity via dynamo mechanism in the sun. So this is my background, and since then, it's probably from 2010 until now, I do in parallel, I do high energy physics, but I also do this solar activity as a part of my satisfying my curiosity and answering the question for people. Turn out there are many questions which were required to be answered.
Thank you very much. To address the possible arising question of why we approached you, as so much it is also multifaceted. As touched on in our October 7th Israeli Intelligence, Security and Leadership Failure series, and later mentioned in the following IDF interview, there's a principle called the 10th Man, coined by filmmakers Mel Brooks' son and author of World War Z, historian Max Brooks, whom suggests that the principle was created after 1967, which basically is a post which has to look and prepare for the possibility that everyone else's consensus is wrong. A sort of devil's advocate or pessimist on duty, if you will, or more mainstream formulations about following masses. So, at least in my opinion, there are many reasons to take notice of your research, so we thought possibly we could raise some awareness and possibly enable at least a few to take appropriate action if your predictions keep coming true, on which I would like to ask you to elaborate a little on.
So what will happen? Currently, solar activity index is defined by sunspot numbers. So I've shown you what are the sunspots. These are dark spots on the sun. It's visible with the eyes without any instruments. And these dark spots are counted, and they were counted for the last 250 years. And people built a large catalog of sunspots. Some of it is shown there, the number of sunspots and the bottom plot, and the butterfly diagram or position of sunspot on the latitude with respect to the equator in the center on the top plot. So this is the solar activity index. After we done this European project, we had the sunspots for the whole cycle 23 for 12 years, and we try to make automated solar activity index. So what we added to this sunspot, we added magnetic field in each sunspot, because sunspot actually are the roots of magnetic loops embedded into the photosphere, like shown in this picture.
Mm-hmm.
So we added this magnetic field, and we had all the data required for sunspots, and we were trying to emulate the solar magnetic field reversal during the solar cycle, governed by solar dynamics. So the cycle at the start, the minimum north and south, north on top, south at bottom, and over 11 years, the polarity of magnetic field changes, and on the north, on the top will be south, and at the bottom will be north. So this is what we're trying to do with originally with our data, to define the automated classification of sunspot. But it turned out it is not so easy, because sunspots are very tiny part of the solar surface, and it was not possible to do automated because it gives large errors. Then we look at the magnetic field. This is the magnetogram of the sun. So for magnetogram, we can use the whole disk of the sun and put this magnetogram into the longitudinal development versus time, and build magnetic field variation in each cycle. And it turned out that the magnetic field has the similar butterfly diagrams like sunspot. So it suddenly occurred to me that probably this magnetic field gives us more information, because what we have now, we have 1024 by 1024 pixels in each image. So we can use this image, and instead of 1,000 of those which come in sunspot and gives you huge error, we can use this magnetic field. So we use this magnetic field, discovered that magnetic field of background is opposite polarity than magnetic field in sunspots, and we discovered that sunspots appear where the background magnetic field allows them to appear. So this was the main work done in 2008. And after that, we decided to look at this magnetic field. We use synoptic maps for the existing synoptic map from the Wilcox Solar Observatory, and use the principle which we use for white light emission. So if you put white light into the prism, glass prism, because of the different diffraction, you see that the white light which doesn't have wavelengths suddenly got split into clear wavelengths, red, yellow, green, blue, in Berkshire. And this is, we needed to find this kind of prism for magnetic field. And the prism for the magnetic field turned out to be is well known.
Valentina, I would
and
have to ask you to repeat your last two sentences. Your signal was breaking off, sorry.
Oh, really?
So
okay.
When we got to the light spectrum, please repeat from that on, sorry.
So in order to detect something from magnetic field, we needed to detect noise. And for this purpose, we remembered that when you put white light into the glass prism, then because of different diffraction of light with different wavelengths, we split it into the rainbow on the right hand side. Red, yellow, green, blue, up to imbir. And this principle we needed to find for magnetic field. What can act like this glass prism for magnetic field? And this mechanism is called principal component analysis, which allows you to detect unnoised signal from the data where all the signals are put together, like in the white light. So this is what we done. We detected the eigen values of different wavelengths of the magnetic field. And what we discovered on the left-hand side, this is eigenvalues. shown by green and red light, red arrow. And what we discovered that these eigenvalues and corresponding to them eigenvectors came in pairs. You see this first pair too close together, then the second pair at the bottom, and the other two pairs in there. So we stop at the 5%. The eigenvalue is defined by variance covered by this particular data. So the first two principal components, they cover 39% of variance of the data. And they're defined by magnetic field of dipole. And this is, skip this one. This is what the waves we detected using principal component. Blue and red, they had different polarity. Each of them start at the beginning cycle different hemisphere. Then they travel to the hemisphere in which will be dominant. And when they have equal amplitude, they reduce very strong resonance, and this is where the main activity started. So this is cycle 21, 22, 23. Then we managed to, for cycle 24, we managed to predict cycle 24 using this approach, symbolic regression analysis with Hamiltonian approach by Schmidt and Lipton, 9 Science, and so-called Eureka software. So when you put those unnoisy waves to principal component, this software gave us this very nice formula for each of the components. And all these coefficients are calculated. So we substitute the formula, and now we had the formula to calculate it all 1,000, 2,000, 100,000 years. So this is what we managed to discover. Plus, we calculated summary curve of these two components. So we added them together, and this is how it looks like. And we try to understand what the summary curve means. And what it means, actually, it means similar like SunSpot numbers. So we discovered this is red, our SunSpot number measured, and the black line is our summary curve, for which we published in paper 2015. And then recently, 22, we extended the summary curve. We used the data from cycle 24, and then again, red are SunSpot numbers, and this summary curve, which show that summary curve actually is a solar activity index, but taken from different field. If sunspots are toroidal field or field strong field where magnetic field is very strong within sunspot, what we are dealing is poloidal fields, a weak background field, but obviously they have very close behavior, and the periods are more or less close. But what comes most interesting that this is when we discovered that after cycle 24, the amplitude of the solar cycles will dramatically reduce. So first in cycle 25 slightly reduced compared to cycle 24, but in cycle 25 reduced by 70%, which we needed to calculate now to much longer period. So what we did, we basically tried to calculate some other period. Just keep this. We calculated the summary curve for 2,000 years from 1200 to 3200, and these are the data shown by ellipse we used. And what we discovered that what we're approaching on this part, we're approaching ground solar minimum. And this ground solar minimum, which we had before Dalton and Maunder minimum, and then before it was Wolf minimum, and there will be another ground solar minimum upcoming in the future. So we discovered in 2015, and standing just before the ground solar minimum, which was supposed to start at 2020. So you see the website when you can download the paper. So this is what results were reported in many media presentations. If you look at the presentation from 2015, 2018, these results were widely covered. So this is what we discovered, that we are in the front of the ground solar minimum, which means that if you look what happened with the ground solar minimum before, it was Maunder minimum. We can look it was ground solar minimum wolf, which is what Oort, and this is even Homeric ground solar minimum. We hit all of them. So ground solar minimum is related to the ground solar cycle having 350 or 400 years. And while this cycle appeared, I take you very nice bit of which I show to my students when I teach them waves. So we have two waves on the top which run a little bit out of phase. The blue line shows you the resulting wave. So you can see when the waves have close phase, the amplitudes are doubled.
Mhm.
When the wave have antiphase, the amplitude drops down. So this is why we have this ground solar minimum, because two waves which we discovered in the sun, they run slightly out of phase. And then they approach this ground minimum when the amplitude is reduced. And this is why we see the ground solar minimum and saw it before. So this is what we discovered in 2015, and this is where our trouble started, because we were attacked by many people saying, no, it will not happen, this is not true, this is not correct, and everything. And this is how we realized there is anthropogenic global warming. Before, I didn't even look at it because I was doing high energy physics, didn't have time. I had other projects funded by different funding bodies, including the US Air Force. But now we needed to deal with the solar activity and verify our ground solar minimum. So this is how I arrived to the solar activity science and contradiction.
Highly interesting and potentially scary. I think
it wasn't scary at first, because I was saying 2015, the ground solar minimum starts in 2020, so we just wait 5 years and we will see everything, because we are sitting in the front seat.
Mm-hmm.
We cannot avoid it. All people on the earth will be experiencing it.
I think one really underreported aspect of the current media consensus, or perceived media consensus, is that the information that even IPCC officials stated that they could not actually predict if human actions would actually be able to achieve any of the stated goals influence the climatic trends to any capacity. Would you like to address this in particular, Ili, and give us a concerned scientist's definition of the current goals and agenda formulations and their alignment with actual realistic achievements and developments?
I cannot comment what IPCC says, because their conclusions are based on the models, which have assumptions. And we know the models always have some restrictions. Let me remind that 300 years ago, when we had Mount the minimum, the model of our solar system was geocentric, and Spanish Inquisition fought people who were supporting heliocentric system. They invented the model when the planet jumped from one circle to another on whatever reason, and they supported this model considering it is absolutely correct, just not to accept the model with heliocentric solar system. So I think we are in the same position now. Maybe each ground solar minimum is marked with the fight of the model between observation and new model. So this is what I would say, because I can't be responsible for their model. There are many mistakes. I later discovered that they didn't use radiative transfer for explaining greenhouse gases. Yes, they use many different component of the gases. The component atmosphere of the Earth is multi-component manual, but they do not consider radiative transfer, and this is the main deficit in their model. So we cannot rely prediction on the model. What our prediction, this is based on the observations of the sun. Nothing to do with the model. Remember that formula which I derived when we put principal components, we do these two components and we derive this formula. No model involved, only observations. This is the point. Only later we applied the NAMO model and we managed to derive actually this dynamo model, this, by the way, the correspondence of our index model, the summary curve, and average sunspot index. And you see that both our curves producing the same 10.7 years average cycles. So obviously our new introduced index of solar activity is very similar. Also, it defines different magnetic fields. So on the left-hand side, it is a magnetic field of the background sun, very weak one. On the right-hand side, the magnetic field of the sunspot. You see difference by factor 10, much stronger field. So they're different entities, and these two indices should not be exactly the same, but they follow the same trend. And this is what we shown in the monthly notice paper published 2023. If you wish to look, we compared them exactly, shown when they coincide. We've done the full investigation.
So basically we have many assumptions on the one hand, and much of proven data, observable data from your hand.
And they haven't done their homework. This is why they become very scared when we discovered the next step. This grand solar minimum turned out was least of their concerns, because when we got this formula, we came, okay, this is how we done the solar dynamo predictions in 2 layers. And here I explained how the waves interact mathematically. So my students know they call Beats effect. So this is how we got grand solar minima. Mm-hmm. So it's very easy. The bottom is what we derive at the observations at the bottom. And this is what you can produce with the dynamo model when you use not noisy observations principal components. So basically, dynamo model can reproduce general shape of the observable summary curve of the magnetic field. As you see them, more or less similar shapes. Mm-hmm. And then also we reproduce butterfly diagram for Mount Grand Solar Minimum, which you can see the years, 1720 had maximum, 1710 we have maximum, so on. And when they predicted upcoming Grand Solar Minimum, which shows you it will be much less prolonged, only 3 solar cycles, and we still have a little bit in cycle 26 will be many days without sunspots, as you can see on the top graph. Mm. So, and what happened and why it is so important? When you come in Grand Solar Minimum, this is left point is solar irradiance, published Lin et al. 1995. There is a reduction during Grand Solar Minimum, during Mount, about 3 watt per square meter, reduction in solar radiation. 3 watt per square meter, which is about, 0.22% of whole radiance. So from 1366 normal to 1363, only 3. But this reduction causes drop of the temperature by about 1 degree. This picture from Lambert et al. 71 is the group 216. So this is what we expect when we come to the modern Grand Solar Minimum, the similar reduction by about 1 degree average temperature of the Earth. But we know what is average temperature. It's very, generic term, because temperature in the equator and temperature in the middle latitude different. So you need to introduce this average temperature somehow. It will be very strong reduction, for example, on the north of the northern hemisphere and southern of the south hemisphere, and probably not much variation in the equator. So the people who Schindel et al. 2001, they measured how the surface temperature of Earth was reduced during Mount Minimum. This is the part of their images published in the paper, and they also have this website in which these images can be downloaded. So it showed that Europe and North America went into deep freeze, and at the bottom, this color code showed the reduction of temperature, and the most dark places where temperature was reduced by 1 degree, like I shown. So this is how average temperature works. So it's not in the whole Earth, but in some particular domain, and like in Northern America, in this particular location. And the Alpine Glacier extended over valley farmlands, sea ice crept south from Arctics. So, and Dunlop and Sam rivers and canals were in the frost and the ice. So this is what happened, and particularly we probably have not the full extent because mountain minimum was 6 solar cycles. It's pretty long time. This current modern minimum will be only 3 solar cycles, so we will have less. Yes.
Might we even have to expect new ice shields? Gigantic.
Possibly.
Might we even have to expect new ice shields or giant glaciers of ancient times reforming, and if yes, where?
Possibly. I don't know. Because the drop of the temperature related to drop abundances of ozone, and what it affects actually these stable jet streams. So at the moment they have, like on the left corner, stable jet stream around the Earth, and it works perfectly. But when ozone is reduced, because the solar radiation, it starts waving, and the northern temperature, you see, north make excursions towards very much south of the Earth, and this is how the temperature is reduced. This is what's happening, and this is why possibly they expect maybe Gulf Stream will disappear because jet stream started. Everything is possible because they cause giant wiggles. It kicks off North Atlantic oscillation, which start waving like this, and it comes into negative phase and will become very cold, like during mountain minimum. So why we at the moment thinking that we are, apart from our prediction, the observation of sunspots by done Royal Observatory in Belgium shows the number of spotless days in cycle 25 grows much quicker than any other 24 cycles before. So we had increase of this cycle 10-15 when we had Dalton minimum, but not as sharp as now. So we are definitely in the ground solar minimum because increase of spotless day is much quicker, and now it is much bigger than because this picture was taken I think 3 or 4 years ago, so now it's probably even better. So what we have observations. So we had snow in Ukraine, in Carpathian Mountains in July, Spain, Morocco 2022 in April. We had snow and frozen all the vegetables. So this was everything shown. Then we had 2020 snow and frost -2 in Amman, Arabia, first in 150 years. And again, contrary to prediction, James Hansen, New York City will be underwater by 2009. We know the New York City flourishing, no underwater, everything is fine. And the snow in Canada, September 20, May 21, and last year in Canada there were very cold winter, -40 Celsius degree. So we cannot say. Summer snow in the south of Australia and Africa desert had snow in December, which never had before. And this year we know that the desert in Chile had flowers. So obviously it had so much precipitation that desert turns into the flourishing field, meadows. And this is snow blizzard in US and Canada for 2 weeks in December 22, January 23. These are pictures from their newspapers. So, and the late spring snow, it was Australia, New Zealand, 22, 30 November 22. And this year they show the coldest winter in the south of Australia, the record of minus temperature recorded in there. So we have this particular confirmation. Plus we have the seasickness, which is increasing 2018, 2020, and unprecedented winter storms. I'll skip this one. So here these ice sheets grew in August 2012. You see where here, August 2013, they grown much more. And then by now they grown even more. So definitely we don't have ice disappearing. We have increased present of ice, even Antarctica. So the ground solar minimum, modern ground solar minimum, is upon us, is studied with us, and has very unique solar terrestrial connection we have at the moment. So you can ask me you have further questions. What is impact on the Earth? And here are the answers. I'm happy to answer each line if you wish.
Yeah, of course, we have additional questions. So, for example, what would this mean for farming, especially in the north of the equator laying latitude?
Well, for the farming, obviously, if you look at the map how it was during the minimum, it will be very cold. It will be not enough time for vegetation to have. So here the temperature. So if it is cold and temperature reduced, it means that you might have snow in May, and then come again short period warmer slightly, not hot as we used, and then come again in August snow. So it means that not enough time to grow like wheat or other long-term stuff. So maybe we'll be able to grow some vegetables, but you have to be very careful, can put them. So this will put definitely very strong restrictions on this food supply, which will be definitely need to be taken into account. And what annoys most that none of the governments even thinking about that they need to supply actually either artificial greenhouses and energy enough to heat them, or find the places where this will be alternatively grown up, like north of Africa or middle latitude of Africa, and north of southern Latin America, for example. By the way, Chinese entrepreneurs, they know this and take it very seriously. Most of them are buying the land in north of Africa. They know it will be golden land when it becomes shortage of food, and they will be providing very expensive vegetables and whatever fruits for the rest of the world. Mm-hmm. So this is what is expected.
One thing that might come to mind would be Siberian deep gardens, Volipinis, but that would also be a massive effort and only some limited relief at best. What might we expect for the regarding energy outputs of solar panels then, for example?
Well, solar panels do not work under the snow. We know that, don't we?
Indeed.
And again, snow doesn't come without clouds. So by the time, I didn't mention it yet in this presentation, but during the cycle 26, we have a paper showing that the volcanic activity will increase very dramatically in cycle 26, which means there will be many ashes in the atmosphere. And these ashes could cause lots of clouds, and will definitely affect that we cannot get solar energy. But these clouds reduce radiation, even reduced already from the sun, but these clouds will not allow even that radiation which is left from the sun to get, so the temperature will be decreasing because of this volcanic eruptions. So this is the problem which we need to deal. We have basically maximum 5 years left before it starts, because the sun is maximum cycle 25. After next year, it starts moving to this descending phase, and the worst come at the minimum between cycle 25 and 26, which will be next 5-6 years. So not big time scale left.
It is quite interesting how possibly everything might align for a perfect storm, basically a repeat of the 7th century crisis, to which I would like to point out that, for example, Peter Turchin has interesting models mostly focusing on a few factors as economic disparity and age of marriage, which then predicted many historical crises correctly when they actually happened without prior knowledge of actual historic context. So in this regard, I developed a little schematic which can be called the crisis rule of 3, while wrong focus of resources allocation might worsen the next crisis impacts exponentially. So, yeah.
Yes, it is true. And definitely the people in 17th century were more advantageous because they had natural heating system, the fireplaces, and the coal and wood they can pick up from the nature. We now have heaters, electric or gas heaters. If electricity is not supplied, even gas heater cannot heat because it runs from electricity meter. You remember the temperature you put, you need this electric. So we are in much worse condition. You need to prepare the stoves or artificial stoves, like get heating, because if the heating stops, nothing in the modern houses allow you to have heating unless you put your artificial stove into the house and remove the pipe outside, because if you don't remove, you get carbon monoxide and you can die. So this is the main thing which our people who live in 17th century, they knew how to heat the houses. In the modern life, many people simply do not know. Even they put the heaters in, they can.
So actually, we would rather be hard pressed to stop the axing of our fossil fuels and other infrastructure, and not be too optimistic in the regards that wind and solar will be covering us in a potential new ice age.
Exactly. We need as much as possible the fossil fuel and electricity and gas to heat the houses first to keep people alive. Because you remember when it was 2021, it was cold snatch in Texas, and people could not heat the houses. About 700 people died from freeze. They're frozen in their own houses or on the streets, while we don't know much less, maybe 100 less people dying from the heat who have heart condition or something. So the frost is much more dangerous than any heating.
To close out with quite bigger question, so please feel free to elaborate as much as you would like. Which additional advice would you give to companies, policymakers, as well as farmers and homeowners in the expectedly most direly affected regions?
My advice is to think about the energy supplies. Think how you can get energy, because I warn the question is that our power station producing electricity are designed for particular power. And this power base at the main dwelling housing where people live, they're not using this power, they're at work. So the main power during the day comes to the plants and they produce whatever they require to produce. Imagine that it become snowy everywhere and you can go to work. So you sitting in your house, you need to heat it, and the rest of the nation or other sitting in front. So they start consuming the full power, which means that only houses which are close to the power station will be able to get this power, because the rest of the power cannot reach further. They consume everything which was designed by this particular station. So people far away from the station will not get power. So they need to think how they cook their meals. They need to find alternative resources. If they have gas, they hope they will get gas. And or buy portable devices, and how they heat the houses. So some have fireplaces, some can buy can put stoves into the houses and use woods and coal to put heating. So you need to think about alternative heating, assuming that you don't have this central heating anymore. Gas doesn't come, or gas comes but no electricity to start your gas boiler. Your gas boiler cannot run unless you have this exhaust working from electricity. So even beautiful gas boiler would not be able to run. So you need to heat your house. You need to find how you cook your meal, assuming you can find some food, and think how you can find this food. So this is the thing.
So summarizing the agenda and most incentives that people are being encouraged to at the moment might turn out fatal in the coming years. If not for the person, but at least for the wallet.
because they preparing people like global warming, and it will be getting hot, and from hot you can sit into the shadow and put, ventilator or something and feel better. But this will not be the case. And you can put ventilator for energy. You need real energy, which means sometimes maybe your car will be warmer. You can go and sit in the car to warm up yourself, to heat yourself, if your car is diesel or petrol. Of course, not electric cars. Electric cars become most expensive toys standing on the streets. They will not be running at all because they do not run, the battery doesn't run below temperature -2. And if we have deficit electricity to heat houses, and then definitely no one would allow to, charge the batteries for the cars for someone else, if even houses cannot be heated. So this is the problem. The people who put this problem, they didn't learn basics of electric techniques, how the electricity is generated and how it is transported from the station to the people. We can increase the capacity of electric stations, but for this you need to rewire the whole country with the wider wires to put more electricity through. So it is not very straightforward.
Dear Valentina, thanks again for your time as well as these intriguing elaborations, and many, many thanks also that you already agreed to return, that we can reach out to you in the regards of the state of academia crisis, as well as do we really have answers to the big questions as a physicist. Thank you very much again for your time.
You're very welcome. Thank you. Cheers.
Hear you soon again.
See you. Bye-bye.